A bombshell just dropped on the astronomical community, but it wasn't from space. While the West's most powerful telescopes were blind, Chinese observatories released crystal-clear images of the interstellar comet 3I Atlas. This isn't just about a new comet, it's about a seismic shift in who controls our view of the cosmos. This sudden pivot in the observational balance is stirring more than scientific curiosity. It may signal a new era in how we monitor these alien visitors. Let's explore this together.
Strange composition.
What if a visitor from another star system was a complete chemical stranger? That's exactly what we're seeing with 3I Atlas. This object is unlike anything that originated in our solar system. Observations so far have revealed a bizarre chemical fingerprint. Its coma, the gassy envelope around its nucleus, is dominated by carbon dioxide emissions, with a CO2-to-water ratio far higher than any comet we've ever seen. Data from the James Webb Space Telescope confirm this, showing a CO2-rich coma with only trace amounts of water. For comparison, a typical solar system comet might have a CO2-to-water ratio of around 10%, but initial findings for 3I Atlas hint at something dramatically different. This composition tells a story. As explained by cometary scientists like Martin Cordner, such a high abundance of CO2 suggests the object formed in an incredibly cold region of its home star system, a place far colder than our own Kuiper Belt, where even carbon dioxide gas freezes solid. The presence of irradiated ices and complex organics further deepens the mystery, suggesting its surface was battered by high-energy cosmic rays for millions of years as it traveled through the interstellar void. This isn't just a slight variation, it challenges our fundamental models of planet formation, which are almost entirely based on the architecture of our own solar system.
Telescopes go dark.
But what happens when our best eyes on the sky suddenly close, right as this once-in-a-lifetime visitor is putting on its best show? This isn't a hypothetical fear, it's the reality that just unfolded. Major observatories like the Hubble Space Telescope, the JWST, and the European Southern Observatory's Very Large Telescope are the workhorses of modern astronomy. They provided the critical data that shaped our initial understanding of 3I Atlas. But these are incredibly complex machines. In mid-2024, Hubble had to switch to a single gyro mode, a necessary fix that nonetheless impacts its efficiency and scheduling flexibility. The VLT's four main telescopes periodically go offline for the recoding of their massive 8.2-meter primary mirrors, a delicate process that can take a telescope out of commission for weeks at a time. Even the JWST has faced challenges with its instruments. The transcript suggests several of these key Western telescopes went offline just as the comet's activity was evolving, creating a critical data gap. This isn't just bad luck, it exposes a systemic vulnerability in a highly centralized system, a single point of failure that can blind us at the worst possible moment.
China steps in.
Nature abhors a vacuum, and so does 21st century science. Into this observational gap, a new power has stepped in: China. Over the past 2 decades, China has invested massively in its astronomical capabilities, a strategic push outlined in its long-term science and technology development plans. The images of 3I Atlas didn't come from old equipment, they came from facilities like the Purple Mountain Observatory and the Xinglong Observatory, equipped with modern wide-field survey telescopes. These systems are capturing both the comet's detailed structure and the background star fields with stunning clarity. This capability is set to explode with the launch of the Zhentian Space Telescope, a 2-meter observatory with a field of view 300 times larger than Hubble's, capable of surveying 40% of the entire sky over its 10-year mission. At a time when Western facilities are dark, observers in China are providing fresh frames of the coma and tail structures. This isn't just about filling a data gap, it's a strategic move that gives them a window to exercise scientific leadership. They have seized a historic opportunity, demonstrating that their long-term investment in astronomical infrastructure is now paying off on the world stage.
Data controls narrative.
Here's what really matters. In science, the person with the data writes the first draft of history. By capturing and publishing the first high-quality images of 3I/Atlas during this critical window, Chinese teams will inevitably shape the scientific narrative. These initial observations become the reference points for all subsequent research. Think back to 1995, when Michel Mayor and Didier Queloz announced the discovery of 51 Pegasi b. Their data showing a massive planet orbiting its star in just over 4 days, created the hot Jupiter category and dominated exoplanet theories for years. Similarly, the Chinese images might be the first to identify key features in 3I/Atlas, setting the agenda for the entire global community. Their interpretations, published rapidly on preprint servers like Archive, will gain significant mindshare before the formal peer review process is even complete. In a scientific ecosystem where reputation and early access are paramount, this gives Chinese teams a powerful boost, allowing them to take the lead on developing the first credible models of this alien object's behavior and origins.
Data sovereignty.
This brings up a bigger, more complex issue: who owns the data from another star system? For decades, Western astronomy, particularly NASA, has championed open data through archives like the Planetary Data System. This democratic approach allows any researcher anywhere to download and analyze raw data, fostering independent verification. However, this is not the only model. The European Southern Observatory often has a 1-year proprietary period, giving the original observing team exclusive access to their hard-won data. As China's infrastructure grows, it can choose its own path. Data becomes a tool of soft power. If institutions like the National Astronomical Observatories of China control access to their 3I/Atlas data, it could create data silos, complicating the creation of a complete global picture of the comet. The decision to release the raw FITS files, the standard format for astronomical data, complete with vital metadata, becomes a strategic choice that impacts not just science, but scientific diplomacy and the very culture of international collaboration.
National prestige.
Let's be clear, observing the cosmos is about discovery, but it's also about power. Space science is deeply intertwined with national pride and global influence. China has long used its space program to showcase its technological prowess. The Chang'e 5 mission in 2020 returned 1,731 grams of lunar material to Earth, the first sample return in over 44 years, a massive prestige victory. Releasing key images of a rare interstellar wanderer like 3I/Atlas, especially when others cannot, is an equivalent statement in deep space science. The media narrative practically writes itself. China steps up when others falter. This resonates far beyond academic circles, bolstering national prestige and justifying massive government budgets for science and technology, creating a self-reinforcing cycle of investment and achievement. It reframes the 21st century space race as a contest, not just of exploration, but of knowledge generation, positioning China as a leader in a frontier domain, previously dominated by the West.
Infrastructure fragility.
Ultimately, the 3I/Atlas incident exposes a fundamental crack in the foundation of global astronomy. For decades, the field has been shaped by a heavy reliance on just a handful of powerful, Western-funded flagship observatories, many of which are, geographically concentrated in places like Hawaii and Chile, but this model is honestly fragile. This event serves as a stark reminder that our global network for monitoring the sky is just not robust enough. It highlights the urgent need for diversification and support for projects like the Vera C. Rubin Observatory in Chile. Once operational, its 8.4-meter mirror and 3,200 megapixel camera will conduct a legacy survey of space and time, scanning the entire visible sky every few nights. This kind of continuous watch is a direct answer to the problem of missing transient events. The incident also underscores the importance of geographically distributed networks like the Square Kilometer Array, ensuring that no single point of failure, whether it's technical, political, or weather-related, can blind humanity to a critical cosmic event.
Verification questions.
New data is thrilling, but it arrives with a critical question: can we trust it completely? The scientific process is built on verification, and integrating the Chinese data on 3I/Atlas isn't simple. Are the new images calibrated in a way that is fully compatible with previous data? To answer that, the global community needs the raw FITS files and all associated calibration frames, the darks, biases, and flat fields required to remove instrument signatures. Without these, it's impossible to perform accurate photometry, the measurement of the comet's brightness, to see how its activity is changing over time. Furthermore, high-precision astrometry, or the exact measurement of the comet's position against background stars, referenced by the Gaia catalog, is crucial. This data is needed to refine 3I Atlas's hyperbolic orbit and search for tiny non-gravitational forces caused by outgassing. Full transparency, including sharing data reduction pipelines, is the only way for the results to be independently replicated and universally accepted by the scientific community.
What the images reveal.
So, what could these Chinese images of 3I Atlas actually show us? They are far more than just snapshots. They are dense with physical clues. Astronomers like David Jewett at UCLA, who co-discovered the Kuiper Belt, would meticulously analyze the coma for structure. A faint jet, perhaps only a few arc-seconds long, could reveal the spin axis of the nucleus and point to a specific active region. By measuring its surface brightness, one could estimate the dust production rate in kilograms per second and compare it to well-studied comets like 67P Churyumov-Gerasimenko. The transcript suggests that some releases show brightness falling off more rapidly in certain sectors, hinting at asymmetric outgassing. Most excitingly, a rapid sequence of images might capture a fragmentation event. If the nucleus were to split, as Comet C 2019Y4 did, these observations might be the only record of it happening, providing invaluable data on the structural integrity and tensile strength of an object from another star system.
Global wake-up call.
Bottom line, this event is a shock to the system of global astronomy. It's a wake-up call on multiple fronts. First, it forces a reckoning with the fragility of our observational infrastructure. It will likely accelerate pushes for more distributed networks and formalize coordination through frameworks similar to the International Asteroid Warning Network. Major observatories will likely re-evaluate how target of opportunity time is allocated to ensure that high-priority interstellar objects get immediate, coordinated follow-up. Second, it recalibrates the geopolitical landscape of space science, forcing Western institutions to forge new alliances and advocate for more resilient, internationally managed observatories. Finally, it shines a light on the changing nature of discovery itself. It's becoming less about a lone genius at an eyepiece, and more about managing vast, complex, and sometimes fragile global systems of technology, data, and collaboration. The 3I Atlas event is a powerful case study in this new scientific reality. What do you think this shift means for the future of astronomy? Is this increased competition a good thing for science, or does it risk fragmenting our global community? Let us know your thoughts in the comments below.
Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos.
Thank you for watching Space Fact. What if the most significant discovery in astronomy wasn't just another space rock but something far more extraordinary? Recent observations of 3I Atlas have revealed characteristics so unusual that some scientists are questioning everything we thought we knew about interstellar visitors. This cosmic wanderer's behavior is challenging our understanding of what's natural in the universe. Discovery and initial detection. What are the odds of spotting a cosmic needle in the infinite haystack of space? On July 1, 2025, the Atlas telescope in Rio Hurtado, Chile, achieved exactly that, detecting a faint moving object initially catalogued as A11PL3Z. This discovery marked a historic moment as astronomers realized they had found the third confirmed interstellar object ever detected by humanity. Following the groundbreaking discoveries of 1I Oumuamua in 2017 and 2I Borisov in 2019, this new visitor was officially designated 3I Atlas, and given the cometary classification C 2025N1. However, what makes this detection particularly intriguing is that despite its eventual brightness, 3I Atlas remained hidden from earlier detection due to its challenging viewing angle as it approached from the direction of the Sun. This late discovery, despite the object entering our solar system months earlier, raises questions about how many other interstellar visitors might have passed through undetected. The object's trajectory and timing suggest it may have been deliberately positioned to avoid early detection, a characteristic that has captured the attention of astronomers worldwide. Within days of confirmation, observatories globally began tracking this mysterious visitor, but its behavior would soon challenge conventional explanations for interstellar objects. Extraordinary orbital characteristics. How can an object from interstellar space follow a path so perfectly designed for studying our solar system? 3. I-Atlas possesses orbital characteristics that defy the laws of probability and challenge our understanding of random cosmic motion. The object follows a hyperbolic orbit with an extreme eccentricity of 6.14, making it the most hyperbolic trajectory ever recorded for any confirmed interstellar object. Racing through space at an incoming velocity of 58 kilometers per second, it holds the record as the fastest interstellar visitor humanity has ever detected. What makes these characteristics truly extraordinary is the object's trajectory alignment. Its path lies almost perfectly within the ecliptic plane, with astronomers calculating only a 0.2% probability of such alignment occurring by random chance. This precise positioning allows 3 I-Atlas optimal viewing angles of all major planets in our solar system, resembling a carefully planned survey route rather than the chaotic trajectory expected from a naturally ejected object. The mathematical precision of this path has prompted some researchers to question whether natural gravitational interactions alone could produce such an unlikely orbital configuration. Unlike typical interstellar objects that enter our solar system from random directions, 3 I-Atlas appears to follow a route specifically designed for comprehensive planetary observation, raising profound questions about the true nature of this enigmatic visitor from the depths of interstellar space. Suspicious planetary encounters. What are the chances that a random visitor from interstellar space would pass by every major planet in our solar system? The trajectory of 3 I-Atlas presents astronomical improbabilities that challenge conventional explanations for natural objects. Calculations reveal that this mysterious visitor will pass unusually close to Venus, Mars, and Jupiter, with astronomers determining only a 0.005% probability that such planetary encounters could occur by random chance. Even more suspicious is the timing of its closest approach to the Sun, which occurs precisely when Earth's position blocks optimal observation opportunities, an event with only a 7% probability of random occurrence. This strategic timing ensures that 3 I-Atlas remains partially hidden during its most vulnerable moment of solar approach, when increased solar heating would reveal the most about its composition and internal structure. The object's path resembles what mission planners would design for a reconnaissance spacecraft conducting a comprehensive survey of our solar system. Each planetary encounter provides optimal positioning for studying gravitational effects, atmospheric compositions, and planetary characteristics that would be valuable to any advanced civilization seeking to understand our cosmic neighborhood. The mathematical precision required to achieve such a trajectory through natural ejection processes appears virtually impossible, leading some researchers to suggest that 3 I-Atlas might represent something far more sophisticated than a simple interstellar comet drifting randomly through the galaxy. Physical properties and anomalies. How can an object be simultaneously ancient beyond imagination yet surprisingly well preserved? 3I/Atlas presents a fascinating paradox in its physical characteristics that, honestly, challenges our understanding of interstellar object evolution. With an estimated diameter ranging from 1 to 12 kilometers, it's significantly larger than previous interstellar visitors, making it the most substantial confirmed object from beyond our solar system. Age estimates suggest this cosmic wanderer is over 7 billion years old, predating the formation of our entire solar system by billions of years. Despite its ancient origins, 3I/Atlas has earned the distinction of being the brightest interstellar object ever observed, reaching magnitudes that allow detailed study with ground-based telescopes. The object exhibits a 29-hour rotation period with remarkably minimal brightness variations, suggesting an unusually spherical or elongated shape that maintains a consistent cross-sectional area as it spins. What puzzles astronomers most is how an object of such extreme age could maintain its structural integrity during billions of years of interstellar travel, surviving impacts from cosmic dust, radiation bombardment, and gravitational perturbations from passing stars. The preservation of such an ancient artifact raises questions about its composition and internal structure. Most naturally formed objects of this age should show significant weathering and fragmentation, yet 3I/Atlas appears remarkably intact, leading some researchers to speculate about unusual material properties or construction methods that could explain its extraordinary longevity. Comet-like features versus anomalous behavior. Why does 3I/Atlas simultaneously behave like a typical comet while displaying characteristics that contradict cometary physics. This interstellar visitor presents a confusing mixture of expected and anomalous behaviors that have astronomers scratching their heads. On one hand, the object displays clear cometary features, including a faint coma and a short 3 arc-second tail, indicating active outgassing as solar radiation heats its surface. Spectroscopic observations confirm the presence of water vapor and dust particles being ejected from the nucleus, creating the familiar fuzzy appearance associated with comets approaching the Sun. However, several characteristics deviate significantly from typical cometary behavior and challenge conventional understanding. Unlike normal comets that develop extensive flowing tails as they approach the Sun, 3I/Atlas maintains a remarkably compact and dense appearance despite its proximity to our star. The expected dramatic tail development that should occur during solar approach appears mysteriously absent or significantly suppressed. Additionally, the object's outgassing patterns don't follow the predictable models used for solar system comets, with activity beginning much earlier and following unusual intensity patterns. The combination of recognizable cometary features with anomalous behavior patterns creates a scientific puzzle that defies easy categorization. Some researchers suggest these contradictions could indicate an artificial origin designed to mimic natural cometary activity, while maintaining structural advantages that prevent the typical fragmentation seen in natural comets during close solar encounters. Scientific debate: natural versus artificial. Could humanity be witnessing the first confirmed artificial object from another civilization? This question has sparked intense debate within the astronomical community, with Professor Avi Loeb from Harvard University leading controversial discussions about 3I/Atlas's potential artificial origins. Loeb points to the statistically improbable trajectory, precise planetary encounter timing, and anomalous physical characteristics as evidence that this object might represent advanced technology rather than natural formation. His arguments center on the mathematical impossibility of achieving such a perfectly designed reconnaissance trajectory through random gravitational ejection from a distant star system. The object's strategic positioning for optimal planetary observation while minimizing detection opportunities suggests intentional design rather than cosmic coincidence. However, the majority of the scientific community strongly opposes these interpretations, dismissing such claims as irresponsible speculation that, honestly, undermines serious astronomical research. Leading planetary scientists argue that unusual characteristics can be explained through natural processes we don't yet fully understand, pointing to the complex dynamics of planetary system formation and ejection mechanisms. They emphasize that extraordinary claims require extraordinary evidence, and current observations, while puzzling, don't provide sufficient proof of artificial construction. The debate highlights fundamental questions about how we interpret anomalous data and the criteria required to consider non-natural explanations. This scientific controversy demonstrates the challenges of studying truly unprecedented phenomena that push the boundaries of our current understanding. Spectral analysis mysteries. So, what happens when the chemical fingerprints of an object contradict everything we know about cosmic ice? Well, spectroscopic analysis of 3I/Atlas has revealed some pretty puzzling discrepancies that, honestly, challenge our understanding of interstellar object composition. While initial observations detected the expected water ice spectrum, a more detailed analysis actually reveals significant anomalies in the spectral patterns. The observed signals rise precisely where theoretical water models predict they should drop. And this creates a scientific puzzle that's got researchers questioning their fundamental assumptions about cometary composition. This unusual spectral behavior suggests either unknown ice structures formed under extreme interstellar conditions, or maybe even the presence of exotic materials not found in typical solar system objects. The object's distinctive reddish coloration adds yet another layer of mystery, resembling asteroids from the outer asteroid belt, rather than the neutral or blue colors we usually see in pristine comets. Standard models just can't adequately explain this color combination along with the observed outgassing patterns, which suggests some pretty complex surface chemistry, likely altered by billions of years of cosmic radiation exposure. And to complicate matters even further, the active coma surrounding the nucleus interferes with spectroscopic measurements, making it tough to distinguish between emissions from the solid surface and gases in the surrounding cloud. Advanced computer modeling, which tries to separate these contributions, has so far yielded inconsistent results, with some analyses even suggesting the presence of materials that really shouldn't exist in natural cometary bodies. These spectral mysteries have prompted some researchers to consider whether 3I Atlas might contain artificial materials or, maybe even represent a type of object completely unknown to current astronomical science. Dark forest hypothesis implications. Could 3I Atlas represent evidence of a cautious alien civilization following the theoretical dark forest hypothesis? This controversial idea suggests that advanced civilizations, remain hidden to avoid detection by potentially hostile neighbors, conducting reconnaissance missions while minimizing their own exposure. The behavior of 3I Atlas, honestly, eerily matches this theoretical framework, displaying what appears to be deliberate stealth-like characteristics designed to avoid detection during its most vulnerable moments. The object's trajectory ensures it remains partially hidden behind the sun during its closest approach, when increased solar heating would reveal the most information about its internal structure and composition. This strategic positioning allows comprehensive study of our solar system while minimizing opportunities for detailed observation by Earth-based telescopes. The timing and trajectory appear designed for maximum information gathering with minimum exposure risk, resembling the cautious exploration strategy that an advanced civilization might employ when investigating a potentially inhabited star system. The dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, suggests that civilizations remain silent because revealing their location invites destruction by more powerful neighbors. If 3I Atlas represents such a reconnaissance mission, its behavior demonstrates remarkable sophistication in balancing scientific objectives with survival instincts. The possibility that we're witnessing humanity's first encounter with alien technology conducting a stealth survey of our solar system raises profound questions about cosmic civilization protocols and our place in a potentially crowded but silent galaxy filled with hidden watchers. Historical context and lessons. The discovery of 3I Atlas carries profound implications shaped by our previous experiences with interstellar objects and, the scientific opportunities we failed to fully capitalize on. The first interstellar visitor, 1I Oumuamua, caught astronomers completely off guard when Robert Warwick detected it using the Pan-STARRS 1 telescope in 2017. The object's unexpected rapid exit from our solar system left the scientific community with more mysteries than answers, particularly regarding its strange acceleration behavior that just defied conventional explanations. This missed opportunity, honestly, highlighted critical gaps in our rapid response capabilities for studying rare cosmic phenomena. The second interstellar object, 2I Borisov, discovered by amateur astronomer Gennady Borisov at his Crimean Observatory in 2019, provided a redemption opportunity that was better utilized but still constrained by available technology and coordination limitations. Mark Norris from the University of Central Lancashire emphasizes that 3I Atlas represents our most comprehensive opportunity to date for properly investigating an interstellar visitor using advanced instrumentation and coordinated global observation strategies. The improved detection capabilities of contemporary sky survey systems, combined with enhanced international communication protocols, have enabled unprecedented real-time coordination among research facilities worldwide. Michelle Bannister notes that these lessons learned from earlier interstellar encounters have truly revolutionized our approach to studying these remarkable cosmic messengers. Future observations and implications. What will the next few months reveal about the true nature of this enigmatic visitor? 3I Atlas will reach perihelion on October 30th, 2025, providing the most critical observation window in its entire passage through our solar system. Following this closest solar approach, the object will re-emerge from behind the sun in December 2025, offering a final opportunity for comprehensive analysis before it begins its permanent departure from our cosmic neighborhood. Multiple telescopes worldwide are coordinating the most ambitious interstellar object observation campaign in astronomical history, including space-based platforms like the James Webb Space Telescope and Hubble Space Telescope. These coordinated observations aim to resolve fundamental questions about the object's composition, internal structure, and true nature before it becomes too distant for detailed study. The data collected during this critical period could revolutionize our understanding of interstellar objects and their implications for planetary defense strategies. If 3I Atlas proves to be artificial, the discovery would represent the most significant moment in human history, confirming that we are not alone in the universe and that other civilizations are actively studying our solar system. Alternatively, if proven natural, the object would still provide unprecedented insights into planetary formation processes in distant star systems and the evolution of materials during billions of years of interstellar travel. Either outcome promises to transform astronomy and our fundamental understanding of our place in the cosmos, making the coming months among the most important in the history of space science. As 3I Atlas approaches its moment of truth during perihelion, it carries with it the potential to answer humanity's most profound question: are we alone? Whether this mysterious visitor proves to be an ancient comet or something far more extraordinary, it represents a pivotal moment in our understanding of the cosmos. For more groundbreaking space discoveries that challenge everything we thought we knew, subscribe to Space Facts, where the universe reveals its most stunning mysteries. Imagine if something from another star system was racing toward our planet right now. On July 1, 2025, astronomers made a discovery that sent shockwaves through the scientific community: a mysterious object traveling at impossible speeds through our solar system. Meet 3I Atlas, the third confirmed visitor from interstellar space, and, honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely, possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I Atlas joins an exclusive club that includes only one I Oumuamua and two I Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance, it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our Sun, 3I Atlas was clearly not gravitationally bound to our solar system. The Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape, and unlike typical solar system comets that only become active when approaching the Sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics, with a slope of 18 plus or minus 4% per 1,000 angstroms, make it redder than most solar system comets. All these extreme properties mark 3I Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with 1I Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3Y Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the Sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the Sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific goldmine. Why are astronomers around the world calling 3I/Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I/Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the Sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3I/Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that one Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3Y Atlas, its high velocity and early activity, can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, and the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optic systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3I Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for rapid response interstellar visitor encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3I Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3I Atlas continues its ancient journey toward the sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share, and subscribe to Space Facts, where the universe reveals its most astounding secrets.